Hey folks, Quill18 here, and welcome to another episode of our Unity 3D tutorial on how to make tile-based movement, the sort of thing you might see in a Civilization game or a roguelike dungeon crawler type thing. In the last episode, we went ahead and implemented Dijkstra's algorithm. What we think, we actually get no feedback whatsoever. All I can say is it doesn't generate an error. But if I click over here, in theory, we should be getting a path from there to there, but it's all happening in memory. We've got no feedback at all. Before we actually move our person, what we're going to do is actually draw some lines to show what the path was. We'll use debug.drawLine for that, which will mean by default that it'll only show up in the scene, but I might be wrong here. I think if we enable gizmos in the play area, I think it will also show up in here, just so that we can see what's there. It's not a true way to draw lines in game, but it's going to work great for our purposes here. So we'll get to see what our actual path is. And speaking of Dijkstra's, last episode I talked about how there were some errors in the pseudocode on the Wikipedia page. I think I've gone and fixed those now. More consistency in the name of the previous variable here, and I corrected these references to line number here and here as well. Looks like a few other people have done some tweaks to the code to try to clear things up and clarify it and improve it, and they missed the fact that, some of the line numbers changed and that sort of thing. So anyway, that should hopefully be straightened out now. So over here, what we're going to do is, in our unit code, what I'm going to do is if it's got a path, I'm going to get it to draw lines, because as you may recall from the last episode, when we click a tile, we generate a path from our map script. The tilemap.cs script generates a path and then stores it in the unit's current path right over here. So what we're going to do is we're going to draw lines based on that. However, before we do that, something I hadn't quite clicked in yet, the unit has a tile X and tile Y. And this is used, if I can find Unity again, this is used when we actually do our clicking way down here. So this is the code that generates the path for the unit, and it's generating to a destination, which is the tile we clicked on. Well, it starts based on where the unit's current position is, right over here. The source node where we start pathfinding from is selected unit, tile X, tile Y, which are these two variables over here. But if we go and jump into the game, I click on unit over here, and I hit play, you can see the tile X and tile Y never gets set. It just stuck at 0, even though its current position on the screen is 5, 5. So we got to go ahead and assign that. Not only that, but we will actually need a reference to the map in here. Just like how in our clickable tile here, we have a reference to the map. We're also going to need a reference to the map in the unit, because the unit will need to call our function here, which converts tile coordinates to world coordinates. So we're going to go ahead and do a little bit of that right now. So in our unit, we're going to create a public tile map reference. And then in tile map, way at the top in the start, we're going to make sure to set up the selected units variables, which is, so in selected unit, it's got a get component unit, which has a tile X, and we're just going to feed that in the selected units.transform.position.x. We're just going to set it to there. We'll do the same thing for the Y. So this way, in the editor, I can position the selected unit anywhere, and it'll have the X and Y tile coordinates that are appropriate there. And then the last thing we need to do on our selected unit is it wants to know what the map object is, and the map object is simply this. Okay, now our selected unit has that, which means every time we were testing our pathfinding, every single time we were calling what is this function called? Generate path to. We're generating a path from the 0, 0 coordinates, which wouldn't have been terribly useful. It would have been really obvious what was going on once we got in here. Anyway, with all that, let's go ahead and start drawing the line. So we're going to have our update function back, so we draw it every single frame. And what we're going to use is debug.drawLine. Now, we only want to draw a line if we actually have a path. So first, if current path not equals null. Okay, so we know we actually have a path. What are we going to have? Well, current path is a list of nodes. And a node is basically, it's a special custom class that we built, which I can't remember where I stuck. I need my, I closed it at some point. Wow, thank you. I need, where's my list of windows? I need my document browser. You? Pads. Document outline. Thank you very much. Ah, so much better. Do I have to find node in here? We can right click on the word node though, and we can say we should be able to say go to declaration. What the hell? I can do it for this. Is it because it's a file it's inside of here? Oh no, Unity has just gone to crap. I can't click on anything. Amazing. Okay, save and close. Let me try this again. Reopen tile map, because it should be in here. Monodevelop. I recognize monodevelop is poop, and a lot of people say, you know, you should use Visual Studios. There's my node class right in here. Oh, it's going to be one of those videos, you guys. All right. So we've got our node class here, and our node class, I don't remember what my point was, has a list of tile coordinates. Node has an X and Y. So what we're going to do, and current path is just a list of those nodes. So we just have to step through those one at a time and draw a line from one node to the other on the screen. Easy peasy. So we need to track what our current node is. We're going to start at 0, and we're going to loop through them all. Now, we want to loop until we sort of run out of nodes, which logically might be something like current node is less than current path dot count. But we have to remember that we actually have to end slightly sooner, because what we're drawing is a line from one node to another. If you've got let's say you had 3 nodes in total, that's actually just going to be 2 lines, from the first to the second to the third. So we actually have to end a little bit sooner than that, because in here, we're going to say, we're going to be using debug.drawLine. Draw line, not draw array. And draw line needs a start and an end vector. So what we need is vector 3 start and vector 3 end. And start will simply be the node we're currently on, and end will be the next node, which is why we got to make sure to cut out just a little bit sooner. So this is the reason we needed the map object. Is the map object, we wrote a function in there, a very simple one, that converts tile coordinates to world coordinates, because our draw line needs world coordinates, but we have tile coordinates. So it needs an X and a Y in here. There's a function we wrote earlier. So that's pretty simple. It's our current path, current node, dot X, and then the same thing with a Y. Like that, like that. And then the second line is the same thing, except it's going to be the next node. Like so. Now, it's important to note, obviously, this function won't run at all if current path, well, obviously if it's null, or if it's empty, or if it only has one item in the path, it won't have that. Now, I'm hoping, I'm not sure, but I'm pretty sure current path, the way our algorithm works, will include the tile we're standing on. I suppose we're going to find out really, really, really soon. Anyway, we've got that. We're going to do debug.drawLine from start to end. And if we pop back into Unity, we get any errors? Yes. Now implicitly convert float to int. That's here. Our transform position X and Y are both floats, and we're trying to stuff them into an int. And it always surprises me that C# won't just like assume the conversion. But you know, better to be explicit than to have weird little glitches show up that are hard to debug. So that should get rid of that. Okay. Like this, and then if we click, nothing happens. In fact, oh, I made an infinite loop. I'm super good at this game. Woo! Not actually used to Unity actually crashing out when I do an infinite loop. That's new. Probably because I was doing debugs over here. So it's pretty important when you do a while loop to actually increment your little number over there. Let me go ahead and reopen Unity. I'm used to Unity just hanging when we do that. Now if we hit play and we click, well, we get the click, but oh no, we do get the line. Just we can't see it. You can see it's inside of our blocks over here. If we turn on the gizmos, it's there, but it's really hard to see. Oh, it doesn't help that the line is green as well. Okay, we can change the color. Let's, I think, not color. Is it just, does it just use the GUI.color? Or do we pass it another parameter? Hang on. I want to see if I can change the color. Ah, there we go. Color.red, perhaps. That should stand out nicely against the green. I apologize if you have green-red color blindness, in which case you're going to be screwed. We'll use something else. I don't know if blue would be better. I have no idea. We'll use red. And the other thing we want to do is, right now, this is returning something with a Z of 0. So what I'm going to do is I'm going to add in, on both of these, I'm going to add a vector pump it to the next line, which is going to have 0, 0, 1. Hopefully that's the right direction. Like so. Like so. Just to try to bring it forward. Nope, I sent it backwards. Okay. The negative. So now it should be in front of things. Bam. Okay. There we go. So it is working. Again, it is ignoring mountains. We don't have any code in here to take into account the fact that we can't walk through mountains or the fact that swamps are difficult to walk through. Nothing of the sort. Also, we are currently using the four-way connection, so it's not going to do any diagonals. But it's potentially, maybe calculating a path. Of course, these sorts of paths are really easy to work out because there's nothing particularly tricky about them. When you don't have to avoid anything, we could have used simple arithmetic to work out these sorts of lines to get somewhere. So let's go ahead and complicate up our map a little bit by making it so that you can't walk through mountains. So we're going to pop into our code over here. We're going to go to our tile map code. Now, here's the important thing. In our tile map code, in our pathfinding, generate path 2, we have one little bit right in here, which calculates the distance to the next node from one neighbor to the other. It figures out what the distance is. Now this works it works fine here, technically, I suppose. But what we're trying to work on here is we don't actually care about the distance. What we are interested in is what is the movement cost to enter the next tile, which, depending on your game, might just be the distance. But in a dungeon crawler or civ-like game, it's often not the distance. In particular, with diagonals, usually the cost is 1, even though the distance will be the square root of 2, is the actual distance to go diagonally from this center of the tile to this center of the tile. The actual cost in most games will be 1. And then the other thing is, if you're entering something like Swamp, even though the distance is the same from this tile to this tile, as this tile to this tile, the cost might be twice as much because it's difficult terrain. So I'm going to go ahead and leave the distance to function, which is part of the node. You know what? I really should put this in a separate file. Let's go ahead and do that. Let us do that. We're going to go into Unity. I'm going to create a new C# script called node. This will make it a lot easier to keep track of. I'm going to open that bad boy up. I should have done this from the start. In my tile map, I'm going to grab all this node code. I'm going to cut it, and I'm going to paste it here. We will need our generics. There we go. And I think these guys here, they're referencing tilemap.node. We're going to have to get rid of that there. And a clickable tile. Nope, we're fine there. Okay. We would have gotten an error here because there would have been no tilemap.node. It would have just been node by itself. Now we've got a node in its own separate file, which is really convenient. So we've got this distance to function. What we're going to do is we're going to leave it in there because, you know, it's fair enough. But maybe instead, we want a function in here. Actually, I don't even know if it should be a function of this. No, we'll leave it there. In tilemap, we're going to make a new function here. It's going to, I don't know, should it return a float? Sure. And it'll be something called cost to enter tile. And it will simply want a coordinate, int x, int y. Now, in some games, direction might matter, right? The question might be, what's the cost to walk from one tile to another? For example, in a game of Civilization, where you have rivers between tiles, entering a tile from one direction might just be a normal cost, might just cost 1. However, entering from the other direction where you're crossing over a river might cost 2. So you might need to worry about something like that. Here we're going to ignore that. We're going to assume the cost to enter a tile is the same regardless of where you're going. So now, what is the cost to enter a tile? Well, we have our list of tiles, and we know, so tile XY is of a certain tile type. So we have all of our tile types, and tiles XY returns an index to this array. So we have our tile, what's it called? Tile type, TT equals that. So what is the cost to enter this tile? Well, we don't really have that information right now. Here's my tile type info. Obviously, we're going to need to put something like that in there. So let's go and give it a public float. That is going to be something like movement cost. That should probably default to 1, right? Default movement cost of 1 seems reasonable. So here what we're going to do is we're going to return tt.movement cost. Very simple. Now we're going to have to fill in those information. So if we go into Unity and we go into our map, that's where we define all of our tiles. Well, grasslands having a movement cost of 1 is fine. We can say maybe our swamp has a movement cost of 2, and our mountains, you can't enter it. Now, I could have a Boolean here that just makes it non-enterable, and that might make it super clear. Or I could literally just do something like this. It is so expensive that it's effectively infinite. I think that's fine, but again, you could in here have a Boolean that says can be entered. Of course, the other thing to keep in mind is movement types. If you can have a game where you have flying units, walking units, maybe hovering units, then the movement cost might vary based on that unit, in which case you need a slightly more sophisticated setup. But for our personal example here, this is going to be completely sufficient. So we're going to return the movement cost to enter the tile. Now, I'm going to do, yeah, that's going to be fine. The cost to enter tile. So here, we have our, there we go. Alt is our distance to move into that tile. So it takes all of our current distance up to this point and then adds some amount. Now, right now we're using dist2. We'll leave this line in here. We'll comment it out. But instead, what we'll use is we'll use cost to enter tile. We're going to add the cost to enter the tile v. And now we're going to use that. Let's find out if that worked. If it did, our program should avoid our mountains. X, v.y. Play. Click here. Like that. We're now avoiding mountains. We're pathing around our mountains. Also, what's really interesting, I wonder if there's a breakpoint. You can see there. Check it out. So here, you're trying to get to this tile. It's like, okay, I'll trudge through the swamp. But if you go a little bit further, it's like, listen, I'm going to avoid these 2 tiles of swamp. I'm going to go around it because it costs too much. That is pretty cool. And in fact, here, the shortest route to get to this point would have actually been to go here. Slightly shorter. It saves a couple of tiles, right? But because of the swampiness here, it decides to take the long way around here, because this is technically faster, even though it's longer, because we don't have to walk through the swamp. And so what we have here is not a shortest path algorithm. What we have here is a least cost algorithm, a least movement cost algorithm. And that's pretty damn good. I will provide a couple of caveats, though. One consideration that our system ignores is the fact that, especially in games like Civilization, the cost to enter difficult terrain isn't as straightforward as you might imagine. In Civilization, especially Civilization 5, right? If you have a hill has a movement cost of 2, and most units have a movement cost, or a movement point of 2. They can move 2 tiles per turn, but a hill counts as 2 tiles. It costs you 2 movement. So our character is here. If this was a hill adjacent to us, if our character moved onto the hill, that would use up both his movement points, and the unit would then have to stop. That would be the end of his turn. However, if the hill were here, the unit could first move into this grassland, which would cost him 1 point. He would have 1 point remaining, and then he'd still be able to enter the hill tile. Because in Civilization 5, as long as you have any movement left whatsoever, you can always enter rough terrain. It's fine. Now, this is a contrast to some of the older tile-based strategy games where it didn't work that way. Instead, if you didn't have enough movement to enter, you couldn't enter. It would use up whatever movement you had and sort of give you credit for it for the next turn. So, for example, if you had a unit with a movement of 1 that was next to a hill that, let's say the hill had a cost of 3. On the first turn of trying to enter it, you'd just bump up against it, and it would do nothing. On the second turn, you'd bump up against it, it would do nothing. On the third turn, though, you would have accumulated enough progress into that tile to finally enter it. Our current system would successfully do pathfinding for that second example, where you're sort of bumping into the difficult terrain and then eventually getting there. However, it would not properly take into account the Civ 5 style of movement, where you can always enter difficult terrain as long as you have any movement left whatsoever. And we'd have to change things around in that our cost calculations, right over here, the cost to enter tile, where's that? Right over here. Cost to enter tile would actually have to be aware of how much movement your character would likely have when you got to this place. Because if you were trying to enter a mountain or a hill, which normally costs 2, but you only had 1 movement left, well, it'll only effectively cost you 1 movement to get into that tile. As opposed to if you got there and you had 2 movement, then it would cost you 2 movement. And Civilization 5, the pathfinding system, does take that into account. The other thing to note in those types of games as well is we generate the path when you click on the tile, but is there anything that can happen that might invalidate the path? Well, what if someone moves into the tile that you are trying to get into, or moves into your way somewhere along the path? What do you do about that? Do you recalculate constantly? In Civ 5, I believe they only invalidate your path if someone moves into your ultimate goal, the tile you're ultimately trying to get into, or if someone is in your way of the next tile you're going to move into. So if you've got a long path, let's go back to the picture. And again, in Civ 5, I'm pretty sure this will work. So we've got our path that goes along here. If I start walking here, and then at some point someone walks into this square over here, I don't believe it will instantly stop our unit in Civ 5. However, if we had progressed all the way over here and we were about to enter that square and someone was there, I think then it would cancel our pathfinding at that point. But in Civ 5, and again, I'm pretty sure this is the way it works, if at any point anyone ever walked into our end path, at that point we would also set our current path to null and once again prompt the player for movement. So little things like that you constantly have to consider. It's less of an issue if you don't have 1 tile per movement, or 1 unit per tile, because a lot of times you can walk through other units, although sometimes that's only friendly units. What if it's an empty units? All kinds of things like that to consider. So what I want to do is I want to go and put in our 8-way movement at this point, because right now we've got these sharp corners, and really, I really wanted to have the 8-way movement. So that's fine, we can easily do that. We generate our graph over here, and right now we're generating a 4-way graph. So what we're going to do is, I'm going to copy all this and paste it. I'm going to leave the old stuff there. I'm going to remove these comments. Actually, I should leave in the comments about hexes, otherwise I'm going to get emails about it all the time. Tell you what, I'll put this at the bottom. About the 6-way hexes and n-way variable areas like that. So this is the 4-way connection version. And then we're going to have, this is the 8-way connection version. Whoops. Allows diagonal movement. So what we're going to change a little bit is here, if x is greater than 0, then in addition to allowing the movement to the left, we're also going to try to move left and up and left and down, which is going to require checking that we are not at the top or bottom. So if it's greater than 0, then we can move to the left. And if the y is greater than 0, not only can we move to the left, but we can also move left and down. And if the y is less than the upper bounds of that, we can do it left and, so that's left and down. This would be left and up. Great. We'll do the same thing here for the direction towards the right. Copy this. Put in some pluses. And then the north and south work fine. So try left. Try right. Try straight, up, and down. So now, with this simple change, assuming I didn't screw anything up, we should be able to pathfind along diagonals. Let's try our same movement test as before. Bam! Look at that. How sexy is it? You will notice one weird thing going on here. What is this? Should it not logically be shorter for our character to walk once it reaches this point here, shouldn't he go straight here? Well, there's a good reason why he's not doing that. The reason is, in our current model, the movement cost to move from here to here is 1, And the movement cost to move from here to here is also 1. And in Civilization and in most tile-based roguelike kind of dungeon crawlers, that's true. Moving diagonally still just costs you 1, even though, yes, technically it's a longer distance. In most games, like, you know what, it's fine, diagonals will just cost 1, who cares? So this is a perfectly legal and logical move, but it looks stupid. So how do we avoid this looking stupid? Well, it's not so bad, actually. In our calculation for the, what am I looking for? Cost to enter, okay? All we're doing, and I said before, all we're doing is figuring out the cost to enter the tile, regardless of where you're coming from. But what if we did consider where we were coming from, and simply added a teeny tiny extra cost for diagonal movements? Just a little to break ties. And that's the problem here. There's a tie, and the game is just not necessarily picking the thing that we would most likely want as the tie resolution. Depending on how you order your neighbors, when you generate your neighbors, generate pathfinding graph, when you generate your neighbors, depending on what order you generate your neighbors in, this will have an impact on the tie breaking. But let's go ahead and make it a little bit explicit by just goofing around. So we're going to say source. We're going to rename this to source X, source Y, int target X, int target Y. So the cost is basically going to be just the target. But, so float cost equals this. And we're returning the cost. Oops. Oh, because I'm missing the semicolon. But if the source X is different from the source, or the target X, and the source Y is different from the target Y, we are moving diagonally. Fudge the cost for tie breaking. Now, all we're going to do is add a minuscule extra amount to the cost when you're moving diagonally. And this should cause it to prefer straight lines as opposed to diagonals. It's purely a cosmetic thing. Here. Really a cosmetic thing. And that's the thing with a lot of pathfinding stuff and a lot of things in computer games. There's a way to do things that is technically correct, but if it doesn't feel right to the player, then that is not a success. So we have to change where we are using the cost enter tile. We have to make sure to specify the source tile, which is u.x and u.y. There we go. So now if we rerun this example and we click here, you can see it now prefers to go in a straight line. Everything else is the same. And, you know, the movement, either way, it was perfectly legit and legal movement. But now it prefers to go in a straight line and it feels better. It's still interesting. It still takes a long way around. Avoids that marsh. If I click there, it'll do that. If I click here, it'll do that. If I click here, whoa, it actually goes all the way around. Interesting. Which is actually different from before. Before we had diagonals, which allow us to shave a lot of corners off. When I click down here, it actually preferred to go this way, dodge the swamp completely. And now if I do this, it actually doesn't dodge the swamp completely anymore. But the reason is, it doesn't actually have to move through that many swamp tiles because it can move diagonally. What if I do this? Ah, it actually dodges one extra swamp tile. Is this correct? Well, yeah, it's technically the shortest path, and this is probably what you'd want to do. It looks a little bit silly to dart around that way, but it cuts out one whole swamp tile, and remember, swamps cost 2. So it's got all that pathfinding put in there. That's pretty good. Now, what you can do is to actually move your character around. Well, that should be pretty obvious. We could put in some sort of next turn button, and then every time you click it in your unit over here, every time the next turn button is clicked, we just change our position to the next node on the path, and we'd probably remove it. So let's go ahead and do that. Let's go and say something like void move next tile. It's fine. We can make it a public so we can trigger it from other things. So what we're going to do is we're going to grab the first node off the path. Actually, no. Hang on, I'm lying. Well, okay. Take a look. We know from our line drawing, it's pretty clear that the first thing in our current path array is the tile we're actually standing on. And the last one is our destination. So if we want to move to the next tile, what we have to do is, first of all, let's get rid of the old first. So remove the old current / first node from the path. So current path dot remove at 0. Now grab the new first node and move us to that position. Okay, we can do that. So it's current path 0, the new 0. This is the new first path. Obviously, we're gonna have to put in some error checking over here. If current path equals null, return right away. So we remove the first node. Then current path, we can do it another check actually. No, this is going to be okay. So the current path will have an x and y coordinate. So what we need to do is we need to translate this to the world. Yeah. So we want to set our transform.position to be where map.tileCoordinate.world coordinates, and we're going to feed in the tile coordinates, which is simply current path 0.x, current path 0.y. So now we're going to be at the new position. On the off chance, if current path dot count is equal to 1, we only have one tile left in the path, and that tile must be our ultimate destination. So let's just clear our pathfinding info. Sitting on it. Because remember, the tile that is our destination is on the pathfinding. And right now, if we've just... The case here would be there's 2 nodes left. We enter here, and there's 2 nodes left. The one we're currently standing on, and the next node, which is our ultimate target. So first, remove the one we're standing on. Then we move ourselves to the sole remaining node, which is our ultimate target. And then that means our count is 1, which means now we can just say, hey, current path equals null. We're done with you. No need to have you anymore. Good job, though. Thank you very much for that. So what I'm going to do is I'll go ahead and create, I don't know, we'll go create UI, button. It'll create a canvas and an event system and give me a button over here. If we take this and anchor it to, say, the bottom right corner of the screen, and we say move forward. And all we're going to do on our button is we'll add a new thing that listens to the event. We'll just hard code it to our unit. And our unit script has a move next tile function. So every time... Oh, I relabeled it. I didn't actually change the text. There we go. Every time I click the button, that move forward, unit move next tile script will be executed, and we should move forward. So let's go ahead and give that a try. I'm going to click here, and we'll hit move forward, move forward, move forward, move forward, move forward, move forward, move forward. That's great. Note, however, we are moving exactly 1 tile per turn, which may or may not be correct, right? We don't know. Unit will need some sort of movement rate. Maybe it can move more than 1 tile per turn, yada, yada, yada. And then we have to keep in mind how our movement mechanics are supposed to work, like our discussion with Civ before. I mean, we can do something like this. We can say something like movement or move speed equals 2. Hey, we'll do civilization. So every time we move, we can move up to 2 tiles. So while movement speed is greater than 0, int remaining movement equals move speed. While remaining movement is greater than 0, we're going to repeat our previous stuff. Like that. So right now we would move 2 squares per click. Let's test that first. That should definitely be the case. So if I click anywhere here, so if I click this, it should move 2 squares. So it should end us up right there. Oh. Things I always forget to do. We have to decrement our movement. is what I was going to say. Now, right now, I'll go ahead and I'll just decrement it by 1. So we'll just do minus minus. Because we have to remove the actual movement cost. But let's go ahead and give this a test. We'll do that. I'll hit the button. We should end up there. There we go. Now we should end up there. Great. Now, the problem is it doesn't work because if we're trying to walk through the swamp, we'll end up here. Now, if I click this button, swamp has a movement cost of 2. Right now, it'll go straight to the end. That is obviously incorrect. So what we have to do, instead of just removing 1, we have to remove map.cost. Oh, it's not public, is it? Cost enter tile. We'll make this public. Public. Cost enter tile. Oh, it's also worth noting this is a float. And yeah, in something like Civilization 5, while the absolute movement speed of your character is an integer, you can actually use up partial amounts of movement along the way. So we'll make this a float. We'll do this. So map.cost to enter tile. And we're moving from our current spot. Here, there you go. We're moving from our current spot, which is this, to our next spot, which is that. All right, we're currently standing on this 0, 0, which we then remove. And we are going to the next one, which will be the new 0 here after this one is removed, but is currently this 1, 1. Clear as mud? Here, what we could do is I could, let's flip it around. I think it'll be a little bit clearer. Move us to the next tile in the sequence. Right, which at this point will be that. So, get cost from current tile to next tile. Then after this, remove the old current tile, which will be current path dot remove at 0. I think this will make it a little bit clearer how it goes. So 0 is our current spot, 1 is our next spot. So we figure out the cost from one to the other, then we move us to the other, and then we remove the original first tile. And there we go. We'll butt out of this function if ever we run out of counts or run out of stuff to pathfind, or if we run out of movement, we'll also drop out of this function. So let's give that a try now. Move you down here. Move forward. We move 2 steps. We should move another 2 steps. Now we should move another 2 steps and end up here. That was weird. Did anyone else think that was weird? Oh, I think I accidentally clicked on a tile or something. I don't know why we teleported over here, though. Oh, I know why we teleported over there. Anyway, I'm going to hit forward one more time, and we should only move 1 tile now because we're in the swamp. And we do. And we do that, and we finish, and we keep hitting this, and nothing happens. Why did I teleport over? If I click over here, you see the path? See that? What's happening is I'm never updating my my unit's current tile position. I'm never updating that, which I need to do. So we set our position here, but we also have to say, hey, tile X is equal to that. Tile Y is equal to this. And for the sake of, I think it might be a little bit cleaner, we'll do that. Update our Unity world position. Okay, so now if I do this, click there, move forward, decide to change my mind. Hey, maybe I want to come over here instead. It'll pathfind from where I am all the time. If I click here, oh, right. Because I didn't actually specify that you literally can't walk in a mountain, it's technically viable. It's just going to cost me, what, like 99 billion movement points to go into there. But that's technically possible. It'll always try to avoid the mountains. But yeah, I suppose then, with that in mind, I have to go, I was aiming for like minimalism, but in our tile type, we'll have to add a Boolean. Public Boolean is walkable. Have a default to true. But then on our map, we'll make the mountain not walkable. So the movement cost at this point literally doesn't matter. Here, I'll switch it back to 1. It should make no difference. We'll have to make a couple of changes. Clickable tile. We're going to have to check generate path to. So it'll try that. in our tile map, generate path 2. We might still be okay. The important thing is what? Well, I'm in the cost to enter tile. What I could do here, if tt.isWalkable equals false, we can return mathf.infinity. But it still has the problem where if we click on the mountain, it'll still pathfind into that. So we have to choose where we disallow the pathfinding. I could have it in generate path 2, just calf out and not allow that to happen there. Or we could have it in clickable tile. Whereas if you're trying to click into a tile you can't move into, it just dies. I think I might do it here. So I guess we'll null out the path no matter what. But if tile type, actually we can make a helper function or something like that. You can do something like public bool unit can enter tile int x int y. All right, so we'll return true for now. But if unit can enter tile x y is equal to false, we probably clicked on a mountain or something, so just quit out. Return. So in here, we could do a test. We could test the unit's walk type, or walk, hover, fly type against various terrain flags here to see if they are allowed to enter the tile. But right now, all we're going to do is return tile types of tiles xy dot is walkable. We just have a flag like that. And in fact, here in my cost function, cost to enter, I'm checking is walkable directly. I don't want to do that. I want to say if unit can enter tile target x target y is equal to false, then we return an infinite cost. This is for the pathfinding aspect so that we don't pathfind through mountains. And the first check is to make sure that we can't set a mountain as our ultimate goal. The other thing you could do is you can change this around so you can click on tiles that you can't legally enter, and instead you just try to pathfind as close as possible. And basically, the way you would do that is we wouldn't put in this filter. And we'd know that the final node would have an infinite cost. So you could pathfind to it. You can click on the mountain, it'll generate a path that leads you to the mountain, and then in your unit movement script, in here, when you check the cost to enter tile, if the cost is infinite, you could just butt out at that point. That would bring you as close to possible as something that you're not allowed to enter without actually entering it, right? Which could be handy. Hope that was clear. This video has already gone on way too long, so we're gonna have to put in a cut, but if I check now, I can indeed. If I click on a mountain, it cancels the pathfinding completely. Otherwise, everything continues to work perfectly well. Anyway, I think that brings us to the end of this tutorial here. Give me a moment. I think I have a file on my desktop with my civ-like tile movement plots and plans. Impossible terrain, rough terrain, consider tiles with units in them. I think we've discussed all that. Yeah. I mean, obviously, there's a lot to be done visually. So again, this is debug information. If I turn off gizmos, or if you export this project, right? Even with gizmos turned on, that's only within this editor. If you export this project to the web or to Windows or whatever, this debug line drawing will not show up in it. You're gonna have to figure out your own way to draw lines. Maybe you want to use the line renderer. Do a Google for the Unity line renderer. It's pretty handy for drawing lines. Or you might want to do some other type of thing, depending on how pretty you want your pathfinding to happen. This works in turn-based, obviously, but it could perfectly well work in real time as well. There's nothing stopping this from happening in absolute real time. What you would do here in your unit code, basically inside of your update from time to time, you would call move next tile. You can also, and this is one of the things, is maybe you don't want your unit to teleport forward. You actually want to have it look like it's sliding from one direction to the other, which you can do as long as, like, this move forward button would actually become a next turn button. You click that, and what would happen is your unit, instead of instantly teleporting to the end location, would just move over time from one to the other. You'd probably update your tile X and tile Y right away, but your position, you could just have some sort of, you could have a lerp or something, or average. You can go from one to the other. You can have an animation time. Like, oh, I really need to end this video, but okay. Bonus content right here. Actually, I have to end this video because of other reasons. What I will do is I will go ahead and add in a little bit of code to make this animate, and you guys can download my copy of the project, and it will have that little animation. Basically, the cube will just slide from one to the other. That's about it, and I'll add some comments in there about exactly how to trigger, say, a walking animation. If it's supposed to be a soldier, maybe you want to have them go into a walking animation at that point, we can easily do that as well. So download my project, you'll get that little animation code as a bonus, and other than that, thank you very much for watching. As usual, feel free to comment or email me with suggestions and questions, or ideas for other tutorials you'd like to see. You can reach me at quill18@quill18.com, or even at Twitter at just @quill18. That works perfectly fine. And I do try to read all the comments. And if you're not already doing it, make sure to subscribe to this channel for sure, so you don't miss a tutorial. And if you like Let's Plays, you could also subscribe to youtube.com/quill18, which is my main channel where I play video games, and that's awesome. See you next time, folks. Bye bye.